Hello everyone. In this video series, we will be discussing about waves and radiation in detail. This lecture is a simple introduction to wave. So let's get started. Right. Now, the first thing is about waves. Your first unit is about waves. Now, what is a wave? Wave are used to transfer energy, right? And the substance the wave travels through is known as medium. So we all might have observed sea waves, something like this, right? So the waves go up and down, and the energy propagates along the wave, right? So for the energy to propagate or transfer, it transfer in form of waves. So one example of it is your sea waves, right? So in the sea wave, the energy is transferred through the water medium. Similarly, we have another example like light waves, uh, in which the energy is transferred in form of light waves, right? Now, you might have noticed that in deep sea, uh, the waves, they although they move up and down, but maybe if you went for swimming into the middle of the ocean or the sea, what you might have noticed is the waves or any object, if you place it in the sea, in the middle of the sea, it will move up and down, but it will not flow to a particular direction, right? Um, so you might have noticed that in deep sea, the seawater will move up and down as the wave passes through. But as long as the wave doesn't break, something like along the shore, um, the water doesn't flow, right? The movement of water, there is no movement of water, right? Now, what happens in the wave is that the particles of the medium, they accelerate around a fixed position, but the energy uh, travels along the wave. So the particles in the medium, they will not propagate, or they will accelerate in the fixed position, right? But it is the energy which flows through that medium. One very good experimental demonstration which I found is, as you can see in this animation or in this video on the left hand side of your screen, that you have you have a tub in which you have some water, and there is an agitator which is simply generating waves in this closed container. And what we have done is we have placed a orange ball in it, right? So in a short while you might have seen that you place a ball in it, and if we observe that ball, what we see is that the ball is although it is moving up and down, but it is not propagating along any direction. It's simply moving up and down in its own position. So basically, the position of the ball is not changing, right? To illustrate that or to expand on it, we have plotted uh, the wave along with the ball in form of a graph on the right hand side of your screen. So as you can see, this red dot, it is moving along a fixed position, whereas the wave is, as the wave is propagating, this particular ball or this dot, it is moving along the fixed position, right? So what happens in wave is that although the energy propagates, but the particle of the medium, it accelerate around a fixed position. It does not propagate, right? It will simply move up and down along a fixed position, but it will not flow along with the energy. It is the energy which is flowing in the wave. Does it make sense? Yeah. So it is, to give you another analogy, what happens is particles or basically any medium, it has molecules or particles in them, right? So it is something like a relay race where you hand over the stick to the next runner, right? So the particles in the medium, they hand over the energy from one particle to another, right? So the movement of the particle is limited, right? It will move or it will accelerate around a fixed position, but it will transfer the energy. So basically, it is the energy which propagates, right? So you can see in the sea waves or in this waves, the direction of the particles or the motion direction of particles motion, it is along this direction, whereas the direction of energy transfer is along this direction, right? So the particle, they will move or accelerate along its own position, along its own axis, but the energy will propagate along, right? So that's how the energy is transferred using waves. Now, in the example I gave, so in the first slide, I gave two examples of wave. One was sea wave, right? So in in sea waves, basically we can see that we have water as a medium, and the energy is kind of like disturbing the particles in water, and it is propagating along. But another example which I gave, it was for of light waves, right? So in the sea waves, we have a medium which is being disturbed by the energy, and the waves are created. So the energy is propagating in form of waves. But what about light waves? uh, So light is also a form of energy, isn't it? So we all might have heard about like solar panels, right? Which converts light energy into electrical energy, right? And we all know that energy can neither be created nor be destroyed. It can only be converted from one form to another, right? Uh, do we all agree with this? Yeah. Energy can neither be created nor be destroyed. It, it can only be converted from one form to another. Yeah, good. So at least Patrick, he agrees. Yeah, so in solar panels, more or less we know that light energy is being converted into electrical energy, right? So light is a form of energy. That is, we all, using this analogy, we can come to this conclusion that light is a form of energy, right? So it must be propagating in form of a wave, yeah, because we just now we study that for the energy propagates in form of waves, right? So light is also a form of wave. But right now we just studied that light requires, or sorry, the waves they require. Uh, so the waves are used to transfer energy. Agreed. Light is a form of energy which must be propagating in form of a wave. And um, the substance the wave travel through is known as medium. So for the waves to propagate, it requires a medium. It holds both these points. They hold true for sea waves, right? You have water as a medium, and uh, waves are being generated. So some form of energy is being transferred through these sea waves. But what about light waves? Now, light, the very obvious source of light is sun, right? Which is in the outer space. So in outer space, we all know we do not have any air, or basically there is nothing. It is vacuum in outer space. Even then, light waves are able to propagate to Earth, right? So this is because light waves are electromagnetic waves, right? So there are basically two types of wave. One is your mechanical wave, which we have just studied, that they travel through a medium. So basically, mechanical wave, they require a medium. Whereas electromagnetic waves, they do not require a medium, right? So mechanical wave, they disturb the medium, right? And propagate, and the energy propagate through that medium. Whereas in electromagnetic wave, uh, the disturbance is in the electric and magnetic field, right? So we'll discuss about this in a bit detail, but basically, uh, I what I wanted you all to understand is the two types of wave, and the fact that waves they uh, they are used to transfer energy, and they require a medium, but there are some other types of wave which can propagate without any medium, right? We'll discuss how these electromagnetic wave or light waves they propagate, right? Now, obviously, we have studied about mechanical waves right now. So one example is your sea waves or water waves, right, which passes a particular point, and some of the water bobs up and down. We have seen that in the experiment. If you place a ball on it, the ball will simply bob up and down, right? It will not move in a particular direction, right? Either left or right. It will simply pop up and down. And another example of mechanical wave is your sound waves, right? So we'll discuss about this. There is a difference between the waves in the sea and the sound wave, right? So basically, we'll divide mechanical waves further into two parts now. But for the time being, let's see the interesting part, which is sound waves. Generally, the speed of sound wave in air is 340 meters per second, right? Although it varies with temperature and humidity, right? But for electromagnetic waves, so one of the example is your light wave. The speed of light in vacuum is 3 multiplied by 10 to the power 8 meters per second, right? So you can imagine how fast I mean these light waves or these electromagnetic waves are in comparison to mechanical wave, right? So sound waves, they require 300, and they travel at 340 meters per second, and the light waves or other electromagnetic waves, they propagate at uh, maybe a million times faster, right? Okay.
So, we will continue our discussion and study about different types of wave in a little detail in our next video. Thank you.